Hello, welcome to my channel. Now this is going to continue the series of finding 4 in a row. Now what I'm going to do is I'm going to do a function that what it's going to do is when we're going to search the board, and this function will take the color, it will take the board, and it will take the index. If it will just take it will take an index. However, we're going to use it in another function that's going to search the board. So what this other function will do, we'll tell this other function to search the board until we find a red. So say it find a red here, then it will pass it onto this function that we're creating now. So the parameter called us is always, for instance, if we're looking for red, it will be red. So it would land here. So when I say it landed there, that means we're looking for yellow. So what I'm going to do is I'm going to copy it and paste it in then to explain it. Now the directory index is just going to loop. This is just going to loop over the directions. Because say if it landed on 29, say if we gave the index as 29, it needs to loop over all the directions and check for 4 in a line over all directions. Okay? So what it does is we're going to loop the directions. So what this is going to do is, say if we landed on, say if we was looking for, I put yellow in, it will search the board and it will come to the first yellow here. So what it will then do is it will do search all directions that way and that way. That will return, and what it will do, if it lands on 31, can you see how, say the first direction is going to be 1, can you see how it will check the direction there? Then it will check the opposite direction there by times it by -1. So if our direction was 9, if our direction was 10, for instance, it will check if this direction was 10, for instance, one of them will check 41, start at 41, and the other one would start at 21, and they'll go. That one will go in that direction. So that means they'll both return 0. So that will say found count would equal to 1 in that case. However, say if you start at 31, one starts at 30, the other one starts at 32. Can you see these two here? Our index directory, our index time -1. So they both start in opposite directions. So one would come to 0, the other one will find 3. However, 3 plus 1 is 4, because we already assume, the reason we start at 1 is because we assume that the score that we landed on is our color. For instance, if I'd done it at 33, one of them will find 1, because it will start at 34. The other one will find 2, because it started at 32. When you add them together, it comes to 3, and the count started at 1, so it will be 4. So this way, in one loop, we can check both directions. So I'll demonstrate it now. If I set it to 33, I'm going to blank this line out here, and I'll tell you why in a bit. If I set that to 33, it found 4. Now I'm going to do something that we wouldn't do, but I'm going to do it anyway. I'm going to check square 30. The direction is 1, and that's going to find 5. Can you see? Okay, it starts at 1. It starts at 1, and then it goes 1, 2, 3, 4, 5. But that wouldn't happen in a game because the reason why it wouldn't happen in the game is because the square that we start on will be our square, so we wouldn't start here and do that. Okay, so that's why that wouldn't happen. Now the reason I put this line in is I could put count equals to 4, and then a circumstance might happen when it's equal to 5 and then it won't work and I'm gonna mess up all my algorithms. So what I can do is, instead of, all I'm interested in is it more than 3? If it's more than 3, then I can set it back to 4. So that means I can say to myself, if it's 4, then it found 4 in a line. If it's 1, it didn't find 4 in a line. And that's all I'm interested in. So if any situation happened where it found, where, I don't know, say if them 3 were yellow, and then say them 3 were yellow, and some situation happened where, say if there's a situation where you dropped one square one and then it found 5 in a line, then that may be impossible, but I haven't tested that theory. I don't have to test the theory, because all I have to do is put that one line in there and put greater than, and even if something happened what was unexpected, it doesn't really matter to me. So also, at the moment I'm hard coding that to 3, but however, in this game we may play a game and we may do a big board and we may say let's find 5 in a line. So all I have to do is change that to more than 4, and that will look for 5 in a line. And I wouldn't have to change that. I can leave that as it is. All I have to do is change that one variable. I'm going to hard code it to 3 because I'm going to be doing a lot of testing, and I need it to just be consistent. So I'm going to hard code it for the time being, and then when the game is working with 3, then I can set it to other numbers. But for the time being, I'm going to leave it. So now I've explained how this works. You land on a square. The square is going to be us, which means that if we are looking for red, it will only land on a red square, and then this function will only run when us is known. So therefore, because of that, we can start with the count as 1. And if we landed on 29, there's no need for us to test 29. We can test 38, 31, 19, that, and that. So it saves a bit of time. Okay, thanks for watching the video. Until next time, bye.